nuclear equations. Okay, we're going to review isotopes. So an isotope refers to an atom that has the same number of protons but has a different number of neutrons. All right, same atomic number, same protons, but different number of neutrons. Therefore, they have different mass numbers. Okay, an isotope is represented by writing the element name with the mass number behind it. Okay, so here's my example. I've got carbon 12, carbon 13, carbon 14. These are all mass numbers. All right, I can also write it like this in isotope notation, where the atomic number is on the bottom and the mass number is on the top. Same element, different number of neutrons, therefore different mass numbers. How do I find the number of neutrons? I would just subtract. Okay, so 12 minus 6 would be 6 neutrons. 13 minus 6 would be 7 neutrons. And 14 minus 6 would be 8 neutrons. All right, so isotope notation. So when you see this in these nuclear decay problems, remember the mass number is on top, atomic number on bottom. Okay, so how are we going to solve for these? Well, we're going to use our notes about identifying whether each of the following decay reactions is an alpha or a beta decay. Okay, so let's go back to our notes that you took, and you've got this chart here, types of radiation, right? And then, so we're going to look for these chemical symbols when looking at alpha and beta. So alpha is what we call a helium nucleus. So we're going to see this symbol, helium, mass number, atomic number. Or if it's beta, we're going to see this electron emission. So that's what beta is fast-moving electron emission. All right, so let's look for those symbols and identifying whether it's alpha or beta. Okay, so let's look here. We've got this element here, number 77, because that is the number on the bottom. So let's go find number 77, iridium, right? And it has a mass number of 174. Now remember, it's not going to be exactly what it says on here because it's elements with different number of neutrons. And it's saying that it's going to decay. And here's this symbol right here, into element number 75, rhenium. So this symbol right here tells me that it underwent alpha decay. All right, and then here on number 2, you can see we've got this element number 52, tellurium. It's undergone decay. What kind of decay? Well, look at this symbol here. That symbol here indicates that we have beta decay, okay? And it's going to decay into iodine. All right, so look for those symbols and tell me whether this is alpha or beta. And we're going to do the same thing down here. Identify if alpha is beta is happening. But when we have these, we're missing part of our reaction, right? So we need to fill these in. So right here, notice I've got carbon undergoes decay. And what do I see right here? I see an electron emission. Electron emission tells me it's beta. Now, how do I finish this off? Because whatever is on the left of the arrow has to equal whatever's on the right of the arrow, which is law of conservation of mass, right? So if I have a mass of 14 here, I need my mass numbers up here to equal 14. So 0 plus what number equals 14? 14, right? And then here I've got an atomic number of 6. So if it undergoes alpha or beta decay, what's going to happen? We're going to increase our atomic number by what? So if you go back here, it says atomic number change in beta, we're going to increase by 1. which would make sense because I've got 7 plus -1 would equal 6. Who's number 7 on my periodic table? It's going to be nitrogen. So I'd put this element symbol. Don't forget the element symbol. You have to have that. Okay, what happens if I undergo alpha decay? So this one's alpha, right? And the same thing happens. Law of conservation of mass. Whatever's on the left has to equal whatever's on the right. So, all right, so right here, we're going to have, all right, we've got 4 plus what number equals 184? 180. 2 plus what number is 74? So we got 72 plus 2 is 74. Who's number 72? Let's look here on our periodic table. And that's hafnium right here, HF. So put your element symbol right there. Okay, so you're going to do the same thing. Fill in the missing blanks. Make sure everything on the left equals everything on the right. All right, when we flip this over, we see that we're going to have to finish all the products. So you're going to put the products for alpha and beta and then finish it off just like I taught you just now. All right, I'm going to do one of these word problems with you. What is the product isotope form when radon 222 undergoes alpha decay? So we've got radon. Let's find him on our periodic table. He's right here. Radon 222, element symbol Rn, element number 86, mass is on top, and it says it undergoes alpha decay. So let's put that symbol for alpha, our helium nucleus, and we're going to finish off the reaction. So if it undergoes alpha decay, what happens? 4 plus what number is 222? Well, that would be 218. 2 plus what number is 86? That would be 84. And who's number 84? It's Mr. Polonium. And so I put my element symbol there. And there's my reaction. So you're going to do the same thing for 17 and 18. Let me know if you have any questions about nuclear equations.